Another basic understanding, general knowledge of science that helps us here are the gas laws. One of the gas laws tells us that anytime a gas shrinks, anytime it decreases in volume, it will actually rise in temperature. If you've done grade 11 chemistry, you will have learned this gas law, that there is actually a relationship, an inverse relationship between the volume of a gas and its temperature. The smaller the volume becomes, the greater the temperature rises to. Conversely, if the gas expands, it will cool down. So we don't need to factor anything else in to explain how we got a sun heated up, because if the nebula shrank, then it will also have heated up according to the gas laws. So as this propelid was contracting under the influence of gravity, it was being squeezed together, and the particles would have been moving faster and faster and faster. The greatest pressure, of course, would occur where? It would occur in the very center of the nebula. That would become the hottest. And so eventually it formed what we call the proto-sun. Remember again, proto means early. So it's not yet the sun. It hasn't started the nuclear fusion that will turn it into a star, but it's the proto-sun, which is a protostar. We think all stars go through this early phase. And as it continued to heat up, it began nuclear fusion, and thus the sun was born. And here we have an explanation for why the sun is in the very center of the solar system, because as the nebula collapsed, that would have been the region that got hot enough to start nuclear fusion. Once the sun ignited, high energy particles shooting out from the newborn sun, what we call the solar wind, would have begun to shoot outwards and would have actually forced the nebular material out of the solar system and far off into space. And that's why today we don't have a solar system that's filled with gas and dust. Because the solar wind has blown it away. The solar wind is still active. When it hits the Earth today, it gets deflected by the Earth's magnetic field. If that didn't happen, we'd all die from the high energy particles. But the magnetic field deflects the solar wind towards the poles, where they collide with air molecules and excite their electrons and cause them to glow or fluoresce in the same way an emission nebula fluoresces, and that creates what we call the northern lights and the southern lights, or the aurora borealis and the aurora australis.